going to start this section today. We won't finish it until tomorrow, and then we will probably, let's see, that would be Wednesday. We might do a quiz Thursday over the quadratic stuff and the complex numbers before going into your, 10 days without school. That might be a good way to wrap up. Because the next section will take me probably 4 or 5 days to get through, so I don't really want to start it and then come back and pick up where we left off. So that's probably the plan moving forward. So in the coming chapters, we're going to be dealing a lot with polynomials and looking at the properties of them and graphs and all that. We're starting with a quadratics as our first polynomial. But I went ahead and put this polynomial definition on here. We are going to see it several times so that hopefully you'll get used to looking at it. It looks pretty scary, but it's not as bad as it appears. So a polynomial function of degree n, where n is a non-negative integer, is a function of this form. Okay, so you have a sub n x to the n plus a sub n minus 1 x to the n minus 1. This is on your notes handout. You're filling in the blank here, writing this down. So basically, a polynomial, you are just adding powers of x. This one's written in decreasing form. It actually doesn't have to be. When we are looking at this, since it tells us n is a non-negative integer, in a polynomial, all of your exponents are non-negative integers. In other words, they're whole numbers. 0, 1, 2, 3, 4. So we can't have negative exponents, we can't have decimal or fraction exponents, nothing ugly like that. Just nice, pretty exponents as we're going through it. So some terms that you'll hear me talk about with this. The degree. That's the highest power. That n value. It does not have to be written first. A lot of times it will be, but it could be anywhere in the list. The leading coefficient. Okay, that is the coefficient of the term with highest degree. So if our degree is n, the a sub n, the a in front of that term, is the leading coefficient. So again, it doesn't have to be the first coefficient in our polynomial. We find the term that has the highest power, and the coefficient of that term is the leading coefficient. The constant is the term without a variable. Okay, in this example, it's a sub 0. There was no x written with that one. So let's look at an example. I want for each of these the degree, leading coefficient, and constant. So what is the degree of this first one? 1. It's an x to the first. So the highest power is 1. The leading coefficient. So we take that term with the highest exponent, and the coefficient of that term is 5. And what's my constant? -1. polynomial, the exponents are whole numbers, but the coefficients don't have to be. So you'll notice like we have a radical 2, but the x is not under that radical, so that's why it is okay to have. So what is my degree? Leading coefficient, so the coefficient of that term, and the constant. 0, because we don't have a term by itself. Alright, last one, degree. 3. Leading coefficient.
2.
Careful.
Oh, whoops. I was in the wrong thing. -1/2.
Yes, you have to look at the coefficient of that term with the highest power. And then the constant. Any questions with this? If our polynomial is just 0, that's what's called the 0 polynomial, and we say it has no degree. The reason 0 is the same thing as 0x, or 0x squared, or 0x to the third. You could put whatever power of x you want with that, and so we can't specify what the exponent had to be, so we just say it has no degree. And that is different than when you have a function equal to another constant. So if I said 3, 3 is the same as 3 times x to what power? Well, if it's to the first, is 3 the same as 3x? What does it?
0.
Okay, what is anything to the 0 power? 1. So if it's any other constant, we just say the degree is 0. A degree is kind of like saying how many variables are there. If you just have a number, there are no variables in that. Alright, so that's some stuff with polynomials, and we will be doing more of that in the coming sections. Today we are focusing on the quadratic function. What is a quadratic function? Right, haven't we kind of seen quadratics already? We've talked about parent functions, we had quadratic. It was something with a square in it. So quadratic is anything of the form ax squared plus bx plus c. When you graph a quadratic, what is the graph? What does it look like? So the graph is a parabola. When we're looking at our parabolas, we have two options. They could either be a normal parabola opening up, or it could be upside down and opening down. If it opens up or down, that determines if it has a maximum or a minimum point. If it's opening up, is this a max or a min? So if it opens up, it has a lowest point. If it opens down, it has the highest point. What's another name for that point?
Vertex.
Okay, what is the imaginary line, that vertical line that goes through the vertex? What is that called? Do you remember? Very good. as far as graphing these things, we have to realize that we might be given a quadratic equation in a couple different forms. The standard form is what we already gave you, the ax squared plus bx plus c. We might also see it written in vertex form. And vertex form is really nice because then it's easy to do transformations to get your graph. You know, it would move to the right h and up k, so your vertex ends up at the point hk. So depending on which form, that will determine our strategy. If it's written in the vertex form, transformations are going to be our option. If it is not, we figure out what we're going to do. So let's take a look. We're going to try to graph some and give the domain range. So if I look at this one, I can't do transformations on that. It's not written in the correct form. So what if I just had to pick points to graph this? Make a t-chart. What do you want to plug in first? Okay. So then we get 0 plus 0 minus 4, which is negative 4. If I put in 1, I get 1 plus 4 minus 1, or minus 4, which is 1. If I put in 2, I get 4 plus 8 minus 4, which is 8. There's my 3 points. Do I have my graph? No. What do I need to do? Okay. Try some points the other direction. So if we put in negative 1. Negative 1 squared is 1. Plus negative 4 minus 4 gives me negative 7. Enough points yet? No. Okay. If I go negative 2, I get 4 minus 8 minus 4, which is negative 8. Is that enough? No. Okay. Keep going. If I put in negative 3, negative 3 squared is negative 9, plus negative 12, or sorry, positive 9 plus negative 12 minus 4, negative 7. Is that enough? Maybe. We can kind of see we have at least found the vertex now. We know where it's changing directions. If we want to do a couple more, put in negative 4, we have 16 plus negative 16 minus 4. So negative 4. If you put in negative 5, 25 plus negative 20 minus 4 is 1. What do you think about this strategy? Inefficient. It is very time consuming. It is taking me forever to get my graph. And even then, I really only found it because my vertex was nice. What if my vertex had been at negative 7/8? Would I have found it just by plugging in points? No. So this worked, but it's not great. It took us a long time. And if your vertex is a fraction, it is going to take you even longer to try to get the graph. So this is not the strategy we want. What's our domain here? our range? -8 would get a bracket. Okay. So, that wasn't great. Let's look at other options. Let's say I give you this one. We could do transformations on this problem. If I'm going to do transformations, what do we have to plot first? Parent function. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9 if you want that many. -1, 1. -2, 4. -3, 9. What are my transformations? What will the negative do? What does the 2 do? So essentially you just need to take your y values times -2. 0 times -2 is still 0. 1 times -2 is -2. 4 times -2 is -8. Same thing on the other side. So we get a square upside down parabola. What is the domain? Range? With a bracket. I want you guys to do the next one. So do transformations, so make sure you're plotting your parent function. Minimum of 3 exact points. Graph it, give me the domain and range. Parent function 0 squared is 0, 1 squared is 1, 2 squared is 4, -1 squared is 1, -2 squared is 4. What's the transformation this time? Right. Domain? Range? Okay, good. So this is great if it's written in that vertex form. Okay, then we can easily look at it and do our transformations. But if it's not, if it's in standard form like that first one, we need a better option instead of just picking up points. So there is a formula for finding vertex. So x equals opposite of b over 2a. That gives you the x value. If you are looking at the Math Excel, it might give you a formula for finding y, but I just find that unnecessary to memorize a second formula. If you have x, you plug that in to get y. And then we're not trying to memorize the second formula. The axis of symmetry, that vertical line going through the vertex, is just x equals that x value. So x equals opposite of b over 2a. That's the x value of the vertex, that is the axis of symmetry. If we do that, we need more points, that gives us 1. How do we get a y-intercept? What is a y-intercept? So basically what we can do is find the vertex, we can find the y-intercept, and then if we think about what the axis of symmetry means, that it's the same on both sides, you can reflect that y-intercept across the vertex to get your final point on your graph. So let's try that on a few. Alright, series of questions. Vertex, axis of symmetry, y-intercept, domain, and range, and graph. So to get my vertex, we have to do the opposite of b over 2a. What's my b value? Over 2 times a. So we get -2 over 2, which is -1. A vertex is an ordered pair. That's the x. To get y, we plug that in. So 1 minus 2 minus 5 is -6. So vertex, -1, -6. Questions on that? The axis of symmetry is a vertical line going through the vertex. Since it's vertical, you need the equation, so it's just x equals the x value of the vertex. And we draw that with a dashed line. Right, we need more points, so an easy one is the y-intercept. If you plug in 0 for all of your x's, you get So we get the y-axis at -5. Minimum of 3 exact points, so to get your final one, you can take this y-intercept and reflect it across the axis of symmetry. So it's 1 away from the axis, so go on the other side, and we've got it. Now you could certainly do more points just by plugging them into the equation, but this is enough for me to get a pretty good idea of my graph. What's the domain? And the range?
-6 to infinity.
Okay. Let's do another one. How do we find the vertex? So a -b would be a +6 over 2 times 3. And you get 1. That's the x value. To get your y, you plug that in. So 3 minus 6 plus 7. What's the axis of symmetry? How do I write that?
X equals 1.
Okay. Vertex 1, 4. Vertex is the point. Axis is the dashed line going through that. And we need the y-intercept. How do we find that? We're in 0 for all of our x's, and we get 7. And then we can reflect that across the axis to get our final point. Domain, range,
4 times A.
you guys try the last one. So vertex, opposite of B over 2 times A, and we get, plug that in, get 5. So vertex is order pair of 2, 5. Is it possible to get like fractions or decimals on that? Yes, absolutely. So don't panic if you get that. Okay, axis of symmetry is the vertical line going through it, so it'd be x equals 2. You have to have it as an equation. Y-intercept, if you plug in 0 for all of your x's, we get -3. Reflect that across the axis, so it is 2 away from the axis of symmetry, so we go to the opposite direction. Domain is always negative infinity to infinity, and the range is going to be negative infinity to 5. Is there a way to know this is going to open down before we actually graph it?
Check to see if A is negative.
Right. If your first term is positive, it opens up. If it's a negative, it opens down. Okay. We're not quite done, but we're stopping here today. There is a Math Excel assignment open. You will notice it's due tomorrow because tomorrow I'm giving a different assignment. Okay, so that is your homework, but it's not like 2 days